This table is going to be used throughout this talk. This is table 8.4. All right, today we're going to talk about bond enthalpy. All right, so it's going to be a very simple video. It's going to be very straightforward. Bond enthalpy is, we're going to say it's the heat energy in a, I can't say covalent, in a bond. So whether it's covalent or ionic, there's heat energy in a bond, and bond enthalpy is the heat energy in the bond. All right, so let's start with an example of this. Let's say we have two hydrogen atoms, and I'm drawing the Lewis dot, and they get together to form a covalent bond. All right, the energy in that bond is going to be 436 kilojoules per mole. So for 1 mole, you get 436 kilojoules of energy. All right, now this is the bond enthalpy. And for this reaction, it's going to be the delta H. It's actually going to be negative 436. All right, so bond enthalpy is that simple. You literally are going to look at the chart. You're going to look at table 8.4, and I'll make sure I post a picture of table 8.4, and you're going to pull the value from table 8.4. So let's do an example. We're going to have chloroform, which is C, H, Cl, Cl, Cl. All right, and we have 4 bonds total. All right, the CH bond, and then we have 3 Cl bonds. All right, so it's going to be, if we look at the table 8.4, the CH bond is going to be 1 times 414 kilojoules per mole. And then the chlorine bonds are going to be, or the carbon chlorine bonds, if I look at the chart, it says it's 331. And then we're just going to add these two up. If we add this out, it's going to total out to be 1,407 kilojoules per mole. All right, so chloroform has a bond enthalpy that equals the bond enthalpy of chloroform. And bond enthalpy sort of gives you what's the stronger bond, what's the weaker bond, as far as energy goes, the amount of energy that goes into that bond. So moving forward, let's do another example. So this time we're going to do formaldehyde. It's in a lot of scented products. It's also used, it's known as a embalming fluid. So it's used to fix cells, and it's used to preserve bodies. And so if we look at the Lewis structure for formaldehyde, we have 2 CH bonds. 1 second. And then we have 1 CO bond. And if we move forward in that, we're going to have 2 times 414. Remember, I'm getting these values from table 8.4. And then it's going to be 1 times 715. So the double bond obviously has a different value than the single bond. And you're going to add these two up. And that leaves us with 1543. So 1,543 kilojoules per mole. And if you compare that to chloroform, that's a higher bond enthalpy. And then finally, we're going to do peroxide. It's a disinfectant as well as a biomolecule. And it also is an oxidizing agent, so it can turn the hair blonde. And we're going to do 2 times OH, because there's 2 OH bonds. If we pay attention, there's OH bond here and here. So it's going to be 2 times OH. And then 1 times OO, because there's an OO bond right here. So if we move that over, 2 OH is 464. And then the OO bond is actually really weak. It's 138 kilojoules. And then by the time we total that up, it's going to be 1,066 kilojoules per mole. So it's really that. So to summarize, bond enthalpy calculations. All right, you're going to get a molecule. In this case, let's do DCM, which is dichloromethane, CH2Cl2. Step 1, we're going to draw the Lewis structure. And we don't really need to put the lone pairs, but that's fine. Then in step 2, we're going to identify the bonds, the different bonds. So carbon-chlorine bonds, there's 2 of those. There's 2 carbon-hydrogen bonds. All right. So that's going to be 2 times CH, 2 carbon hydrogen bonds, 2 times CCl. I'll do like this because carbon looks like a comma or a parentheses mark. And then now all we're going to do is step 3. Get values from table 8.4, and then step 4 is going to be add. All right, so if we go to table 8.4, CH is going to be 2 times 414, and then Cl bond. If I look at the table, it's going to be, let's see, 331. All right. And so by the time I do that math, that's 828. And this is going to be 662. I'm going to do good old long addition. And that's it, right? So we're going to do the same steps like this over and over.